Welcome everybody to the RF Elements Migration to Horns 101 webinar. I am Violetta, the Marketing Director for ISP Supplies. We have a guest presenter today from RF Elements. I would like to introduce Tasha, the Sales Director of Operation in North America. If you have any questions throughout the webinar, please write them in the chat section of your panel. There'll be an opportunity to have your questions answered at the end. Thank you, and please enjoy the presentation.
Good morning, good afternoon. My name is Tassos and I'm with RF Elements, and we'll be doing our Migration to Horns webinar. This webinar will help give you some instruction on how to migrate your networks from traditional sectors to our horn antenna technology. So some of the problems that WISPs face when they migrate to horns is there's just usually some basic questions. They're usually just not sure where to start. You know, maybe you've never really tested our hardware, have never really used it before, so you're not really sure how to start the process of migration from the older traditional sector technology to our horn antenna technology. Perhaps you've used it, but you're still maybe a little unclear again on what the migration path is for decommissioning your older, outdated traditional sectors with our horn antenna technology. For some users, they perhaps tested our horns already, and maybe some of your initial test results are a little fuzzy. You're just unsure if what you're seeing is what you're supposed to see, right? Horn antenna technology is quite different from traditional sectors in the way of how they work. So often you can get kind of confused with the results on whether or not it's actually better. Typically, people kind of judge the quality of their signal based on signal strength alone, right? And they're not really paying attention to the quality of the connection that's there, right? The ping times, the latency of the network, the how solid the MCS rates are, and stuff like that. So some of that stuff, the initial feedback that you get when you first use a horn, again, may give you some confusion as to, again, what's the proper migration path based on the results that you have. Or again, maybe you're just totally lost. Again, you've never heard of this technology before. It's the first time. So hopefully we'll go through some of the scenarios and give you some kind of background information on what to look for when you try to migrate to horn antenna technology from RF Elements versus your traditional sectors. So how do you efficiently migrate, this new technology, right? So one of the best ways is really to kind of follow the best known customer practices, right? So our horn antennas have been used all over the world now. A lot of WISPs are using it every day. Following some of the known methods that successful customers have used with our antennas is a good way to efficiently migrate, so you're not reinventing the wheel, right? One of the other ways to efficiently migrate to RF Elements horn antenna technology is to really solve the problem you're actually having, right? So, you shouldn't just take a horn and put it up because it has the highest gain or whatever it may be. You really need to see what's the problem that you're having. Are you oversubscribed? Are you really trying to cover long distances? Are all your customers close into the tower, right? So depending on the actual problem that you're having delivering quality internet to your customer, you should use the proper horn, and that will allow you to more efficiently migrate your network over, because you'll know how to transition when you try and solve an actual problem rather than just go to horns, and be done with it. Another way or another thing to understand is the spectral limits of your area, right? So again, you need to know what your environment looks like. You need to know what kind of channels you have available. You have to efficiently allocate your bandwidth, your channel sizes and stuff. So understanding the spectral limits of your area is very important. And if you take some time to figure that out before, you'll be more efficient at migrating to our horn antenna technology. And then again, using spectrum wisely. This goes along with, again, channel sizes typically and stuff like that. So, you know, what we find a lot in the feedback we get from customers are, you know, WISPs are going to wider and wider channels, right? And typically this is being done because they need to, you know, they need to deliver more speed, higher speed packages, which makes perfect sense. The problem is that these wider channels are being used because the antenna technology you're using is inefficient. So you're forced to use a wider channel because your antenna is keeping you from delivering the maximized throughput that you could get from a smaller channel, right? So again, once you migrate and you use this technology, you'll realize that in a lot of places you may be able to deliver more bandwidth or the same bandwidth on a 20 megahertz channel on a horn that you were before having to use a 40 megahertz channel on a traditional sector. So you'll see the efficiencies and how that scales, where you can have two APs running two 20 megahertz channels, right? So you have twice the client density, where before you had a single AP running a 40 megahertz channel. So again, horn antennas are very efficient because you could usually run smaller channels and still deliver the same packages you were before. So this gives you the ability of having more AP density because the channel sizes are more efficient when you deliver your signal through an RF Elements horn rather than a traditional sector. So if we look at the breakdown for migrating to horns, there's basically, you know, two methods, right? There's the augmented coverage, which is a hybrid deployment. This is really the most common deployment out there. And this is where you're running your traditional sectors on your tower, as well as using horns for some specific jobs or something like that. So it's basically a hybrid with traditional and horn antennas on your tower. And the second method is, you know, new build outs, basically just nothing but horns, right? So this will be the breakdown in the two methods that we'll look at as we go through the webinar. But before we start, let's just cover a few other topics, right? So it's often thought that with horn antennas, when you're trying to migrate, that it requires a full blown out from the start network forklift, and it's really not needed. So if we look at like your, you know, kind of standard either 320 degree or 490 degree sector deployment, right, the migration path is usually something that you can do over time. So you can decommission, you know, fire up 2 or 3 horns, move all your customers over to the horns, and then decommission that one particular sector, right? So you can do this in a staged fashion as you build out this tower and you migrate to horns from traditional sectors. So going to horns doesn't mean shutting down your tower, you know, taking everything down, putting horns up, putting your customers offline for some time. This actually can happen in real time with practically zero downtime to your customers. If you do it in kind of a staged manner without the need for a full forklift and shutdown of your network. Knowing where your customers are before you deploy horns is really important. We see this a lot. Because traditional sectors have such inconsistent beam patterns and huge and complex side lobes, we find very often that there's a lot of customers are connected to the extreme side, or even worse, the back of a sector. And this typically happens with customers who are close into the tower, right? Because even if you aim your CPE at the back of a sector, because you're so close and there's so much output power and so much antenna gain used in a lot of the CPEs, you actually can get a decent signal. You can get a pretty high intensity signal level from the back of a tower or one of the side lobes that, you know, often you don't realize that's where it is. And this, you know, will make you run into a problem when you decommission that particular tower with horns, because horn antennas have such great isolation that when you fire it up, you'll now have customers that have no signal or very, very, very poor signal. And again, you're kind of disappointed and you don't understand. So it's really important to know where your customers are and making sure that all of them are facing to your original sectors, front of the sector, before migrating to horns, so that way you're not chasing down these customers later and trying to figure out, why they're not getting signal and transition them. Using the right antenna for the job is also very important when you migrate to horns. We offer many different horn antennas, everything from 30 degrees in beam width to 90 degrees wide, and they all have different gains as well, right? So these horns come in 10-degree steps from 30 to 90. So if you have customers that are close into the tower, right, there's really no need to use an antenna that has too high of a gain for the distance you want to cover, right? So this will help you, again, be more efficient, so you're not transmitting a signal too far past your coverage area, which could affect your other towers upstream from there. And also it helps attenuate by using lower gain horns, so you're not hearing as much noise either, right? So using the right antenna for your deployment is really important. And at RF Elements, we give you 7 different horns that can be used in order to match your deployment needs, whether it's density or distance. Again, using the right antenna for the job is really important, and RF element horn antennas give you great flexibility. So, in a challenging environment where perhaps you have to use 2 sectors, maybe you have one sector with a lot of down tilt to pick up your close-in customers because you're in a mountainous area or some valley, and then you have a second sector for customers who are far away. Or perhaps you have a really high density deployment where you need more access points. Using traditional sectors is not the best because you get very wide overlapping coverage areas, and that's a really big no-no when it comes to Wi-Fi type chipsets. With RF Elements horns, if you look on the right-hand side, you're able to use either wider sectors for your close-in customers. If you need density, then you can put up more narrow in order to cover the same area. And what it also gives you is it gives you the ability to adjust down tilt for each of those segments, right? So again, you can control the distance for close-in customers in one segment. You could use less down tilt to go further on another one, and so on and so forth. So again, using RF element horn antennas give you the ability to kind of paint your coverage area where your customers are. And again, this is another breakout of the same thing, right? So if you have to do a high density deployment where you need multiple sectors to cover a 60 or 90 degree area, you could segment that with more narrow coverage areas or more narrow beams. So that way your coverage areas or your signals are not overlapping. This gives you much better isolation, a much better user experience, especially when you're using GPS synchronization and stuff like that. And then finally, a balanced network is a happy network. This is really important. So if we look at a traditional sector, and we look at the kind of customer disbursement in the different areas of the sector, you'll notice something if you look on your deployments. Usually the center of your coverage area is kind of the sweet spot, right? That's where you have your best customer experiences. You have the highest MCS rates. As you start moving to the edge of your sector, that performance starts to degrade, okay? You start getting your chain mismatches where the vertical and horizontal beams don't perfectly match or overlap, so you get signal discrepancies between chain 0 and chain 1, which translate into lower MCS rates. And then what happens on top of that is now you have an access point that has a very large diversity of MCS rates. So the radio is constantly burning up CPU cycles to change the modulation rates to serve these different customers. Where with traditional, with horn antenna technology, because the gain and the beam patterns are so identical that the MCS rates across your coverage area are not as diverse, and therefore your radio is not spending so much time changing modulation rates to serve all those different customers, which give it a better CPU utilization and therefore higher network throughput. So it's not always about the highest MCS rates, because as you know, as you go to the edge, they start to jump around, right? And this becomes an issue. You would get better network latency and a better kind of overall user experience with your customer if your AP had a better average MCS rate across the board than if it has higher modulation rates that are jumping up and down and all around. So basically a balanced network will run better than one that is all over the place. And then finally, understanding your technology. So again, horn antennas are very, very different than the traditional sectors that you've been used to, right? So there's a lot of talk often about symmetrical horn antennas and how, because they have such a large vertical beam width compared to traditional sectors, that they're wasting so much energy into the air. And that's really not the case, right? So yes, it is transmitting higher and there is gain going there. It's not as focused, but you're not losing that 18 dB of gain, for instance, that you're getting as the peak gain. So that's the gain at the bore site or the zero position of your horn. And gain is also bled off in the vertical and horizontal with down tilt or up tilt in the same way it bleeds off at the edges. So it's very symmetrical, and it's very it's very stable, so you can calculate. Another issue or some feedback that comes back is that because it has a vertical beam, such a large vertical beam, you hear so much noise at the horizon. And again, this is really not the case, with when you use down tilt. So again, if we kind of pay attention to this this animation, you see you got full 18 dB of gain at the horizon with zero down tilt. So as you start to either tilt it up or tilt it down, the gain starts to bleed off. So you can see with 12 degrees of down tilt, that 18 dB horn now has only 10 dB of gain at the horizon. So you can really use down tilt to be able to, again, attenuate signal. So for areas where you don't need to go huge distances, you use down tilt and you'll have a much better user experience because the horn will hear a lot less noise at the horizon if you use it properly. So you have to understand how the technology works in order to use it to your advantage rather than think it's a disadvantage. So we talked about the different methods. We're going to take a little dive now here into the augmented coverage kind of methodology for using horn antennas. So augmented coverage is typically used if you're trying to offload oversubscribed APs or just adding additional capacity to your towers, right? So this is one of the methods. If this is the problem you're trying to solve, the augmented coverage could be the good method for you to use. Maybe you're wanting to use our kind of lower gain or smaller, wider horns for close-in coverage, right? Maybe you're doing micro pops, right? So or mini pops, depending on what the distance is, right? Or what terminology you want to use. But basically, you're not trying to go miles with your coverage area. So why use these obscenely high, extremely noisy, extremely sloppy traditional sectors for customers that are only a mile away or less, right? So use our lower gain horns for those close-in customers, and you'd have a better off overall user experience. Maybe you're wanting to use the larger, more narrow horns for high density deployments. Maybe you need to segment a 90 or 120 degree sector or even a 60 degree sector into smaller 30 degree APs in order to get the customer count up, right? As all these new technologies grow, it's kind of a shame, right? So you're able to deliver more and more throughput through higher modulation rates, through wider channels, but in the end, you're still stuck to this kind of theoretical limit of between 30 and 40 customers per AP, right? Now this really depends on what kind of packages you're delivering and stuff, so those client counts can go up. But if you look on average, most people have about 30 customers, and that really hasn't changed in the past 10 years, because as we are able to deliver more throughput, the demand in the industry requires more throughput, right? So you're still stuck at this kind of higher capacity AP because you're delivering more throughput, but you're still at this kind of limited number of customers per AP. So again, if you need more customer density, you need to go to a more narrow horn to get more APs to cover the same area and therefore build up your potential customer count. Perhaps you're, again, trying to add higher throughput packages with horns, right? So maybe you're covering some rural area, right, where the center of town you have business customers, and then out at distances you have your kind of residential packages, right? So maybe you want to sell specialized packages, and you could use horns for these specific customers that are in town closer to your tower perhaps, and use your traditional sectors to serve your kind of lower quality non-SLA type service to your rural residential customers. Or again, one of the other ones is using horns in between your sectors to improve your edge of sector performance. So as I talked about earlier with MCS rates and traditional sectors, as you go to the edge of your sector coverage area, performance degrades dramatically, right? So a lot of people are using horns in between where these two traditional sector beams come together to try and offload those customers to give them a better user experience. So maybe this is the problem that you're trying to solve, that horn antennas from RF Elements can solve for you. So let's look at the offloading or adding capacity. So here we can see kind of two traditional sectors that have poor throughput because they have a high density of customers on there, right? So the AP can't handle that many customers. So in order to kind of add capacity, you could throw up a couple of horns. You can then transition those customers onto the horns, which would offload those from your traditional sectors, and therefore give your older sector less customers to deal with, therefore a lower diversity of MCS rates, and hopefully a better user experience for them. So this is one of the methods that you can use to offload or add capacity to your tower when you're augmenting your coverage, or the hybrid model. Using smaller, wider horns for close-in customers, right? So again, you may have close into your tower, again, either a large cluster of customers. You may have some businesses that are close to your tower, and then again, your residential customers are kind of surrounding those areas, whatever it may be. You could use our kind of lower gain, wider horns to again offload those customers, bring them onto the horn AP, and then keep again your residential or lower SLA type customers on your traditional sectors. So this is another hybrid model method of using horns with traditional sectors. Using larger, narrower horns for higher density, right? So again, maybe you're in a rural area and they just built this little housing development or something like that, or some apartments or something in that coverage area of the sector where you can identify a large cluster of customers that you have within your traditional sector coverage area. This is usually called like spot beaming is what people call it. You could use kind of our narrower horns to point it at that cluster of customers, again, offload them onto the horn-enabled AP, and therefore, again, hopefully bringing up the performance of that what was oversubscribed traditional sector AP. Now you'll get higher throughput and by splitting that off. Delivering higher throughput packages with horns. Again, perhaps you have some businesses in your coverage area, right? So, with these higher SLAs, you have, contracts and penalties and all this other stuff. So, you really wouldn't want to put known high throughput, sometimes symmetrical bandwidth type customers on the same AP as residential customers, right, that have different bandwidth packages, right? So again, you could use a horn antenna to, again, spot beam or just pick up those specific types of customers, again, if they're in the coverage area or within the coverage of a traditional sector. So again, you can offer kind of two different services, and you wouldn't have to put up a second traditional sector and then overlap major beams to try and have a business class sector and then a residential type sector. So horns allow you to kind of segment and cut that area out and be more efficient. And then finally, it's improving the edge of sector performance. So if we look at the kind of customer layout here, you'll see the pins in green are, again, the customers that are usually in the sweet spot of a traditional sector. This is where you have pretty good vertical and horizontal beam coverage. As you go to the edge, again, this is where the vertical and horizontal beams typically don't overlap. So when you get into the kind of area where two traditional sectors come together, you get a very poor performing area. And with horn antennas, specifically our 30-degree horn, because it's a very narrow beam, you can go ahead and light up those areas to offload those customers onto the horn antennas to try and ensure that everybody is kind of in a sweet spot, and therefore a much better user experience for everybody. Again, more available throughput. Again, the more APs you put on a tower, the more customers that you'll be able to serve. So as part of a conclusion to this, sectors are really, they're not the end game, right? The hybrid model, although it's very effective, it really kind of gives you the early feeling that, hey, things are working really good now, but you'll never truly see, what horn antennas can deliver as far as overall network throughput, overall system performance, until you replace all of your traditional sectors with nothing but horns on your tower. That's when you'll really start to see the game-changing technology that we re-innovated and brought to this industry with symmetrical horn antennas, and your ability to reuse channels, to have a network with no side lobes and very low interference and very low latency. So just replace all your traditional sectors with horns eventually as you build it out, and then you'll truly see what your network is capable of, and your customers will get the user experience that they paid for and that they're expecting. So leading in or out of that, we go to the new tower build out. So again, this is obviously pretty simple. This is, different 360-degree coverage maps, based with horns, right? So, we have the uniform coverage where you kind of use that cookie cutter geometric 490s, 660s, 12 130s, whatever it is to get your 360 degrees of coverage. If you're building out a new tower, you can build it with custom coverage based on your customer layout with a mixed number or types of horns, whether it's a couple of 60s, a few 30s, and a 90, whatever it may be. So basically, you're still building out a full 360 degrees of coverage using nothing but horns, but you're basically using horn widths based on your customer disbursement. So if you have an area where they're close into the tower and you have a low density, you could use a wider horn there. So it's not the kind of symmetrical, all the same type of horn covering 360 degrees. And then there's the, adding horns and coverage as it's needed. So this is kind of the going out to a new area where you don't know where your customers are or how the internet or your customer sign-up rate is going to be. So you kind of build your coverage and add capacity as needed. So we'll go through these different scenarios. So again, the uniform coverage model is pretty simple, right? So you're using either 6 60-degree horns, or you're using 12 30-degree horns, and actually this works very well. And the efficiency of the horns and the noise isolation of the horns is absolutely superb with RF Elements horns. In most cases, in the worst case scenario that I've seen is using only 3 channels, so like an ABC type configuration around the tower. So 12 horns using only 3 is the kind of worst case scenario that we've seen. We're seeing more and more customers going to the AB configuration with GPS synchronization, of course, right? So with GPS synchronization, the ability to only use 2 channels with 12 horns is just outstanding. I've seen other manufacturers talk about using only 6 channels with 12 horns, where with RF Elements you can use as little as 2 or 3 channels with 12 horns in GPS synchronization. So our horn antennas are just absolutely fantastic and deliver exactly what we say it's going to deliver as far as performance goes. So there's a difference between an antenna that performs and one that just kind of works. So if we go look at custom coverage, again, this is where you're using one of many different horn antennas to kind of build out your coverage area based on where your customers are, right? So maybe you have areas of your coverage area where you have 0 customers, right? So why would you want to put up an antenna or a traditional sector that might have a side lobe that goes out in that area and can hear noise coming in, right? Never mind sending noise out there. So using a combination of our various degree horns, 30s, 40s, 50s, 60s, all the way up to 90s, you can kind of, again, use the more narrow horns for your high density areas. You could use the more wider for closer in customers, or lower density, or further distances, whatever it may be. So we have again a wide variety of different horn antennas that allow you to, again, build out custom coverage areas so you're not hearing noise in directions you don't want to, and more importantly, you're not creating noise and sending noise in directions where you may want to go later. And then finally, adding horns as coverage is needed, right? So this is kind of, you may go into an area and, you don't want to build it out with 12 30-degree horns. So you may start with 4 90-degree horns, right? And as your customer subscription rate builds and you need density, then you can decommission a 60 or 90 with, again, 30s and what have you. I mean, really any combination that you want to kind of build out that coverage. And the good thing about RF element horn antennas is that the build quality is just absolutely outstanding, right? So, decommissioning a 60 or 90 degree can be easily reused later at a new tower site as you start building them out. So they are highly reusable because they really survive the elements. So again, adding coverage and growing your AP density as you need it is again another smart way to kind of build out these new coverage areas and build as you grow, kind of a thing. Sorry. So in conclusion, to kind of wrap up what we've gone over, right? So using the correct size horn for your coverage area is, again, very important. So, really take some time and think about, where your customers are, what you're trying to achieve, and again, use the proper size horn for the coverage area, or horns, I should say, for the coverage area you're trying to light up and bring business to, right? Know where your customers are before deploying, again, is very important. Again, this kind of goes back to the earlier statement of when you are going from traditional sectors to horns, you'll see customers drop off typically because you may not have known that specific customers were on the back of a sector where when you fire up a horn, those customers may no longer connect and therefore drop off. So, it's good to know where your customers are and make sure that they're actually connected to the sector they should be for the area that they're in. Using down tilt as needed to achieve your coverage goals is, again, very, very important, right? So you don't always have to use very high gain horn antennas to cover specific areas. So use down tilt to attenuate signal where you need to, and run them flat if you want to cover much longer distances. Build a balanced network with horns. Again, this is really important, understanding how the radios work and how radios act or react when you have a very unbalanced MCS rate, right? Where you have a high number of customers with a very high diversity of MCS rates, really becomes very difficult for the radios to handle a really high CPU rates. So building a network that's more balanced with horn antennas versus traditional sectors will give you a much better user experience and a much better migration to horns. And also, again, the hybrid antenna solution is not the best approach. Again, the hybrid traditional sector with horns works great in the beginning. It looks really good because, again, you're kind of offloading a lot of capacity from traditional sector. So now the customers that are left over, are working better than they were before, but they'll never achieve the actual speeds. The network will never have the low latency and everything else unless you go to all horn antennas. So the hybrid model, again, is not the long-term solution. And then finally, plan before you deploy. This is kind of just rewrapping up all this stuff. It just take a little time, right? So don't just go out there and throw the horns up, right? I mean, kind of, do a little research, understand the spec sheets, ask questions, and figure out what you're going to do before you do it. And if you follow these methods, it'll be a very smooth transition for you to migrate your network to horn antennas from that really old, outdated, sloppy, traditional sector technology that we've been using for way, way, way too long in this industry. So I just want to take a little time here to talk about our community. So join our community, rfelab.com. It's our forum. Again, this is a great place for you to get a lot of information. Nobody ever expects a manufacturer to talk bad about their products, right? So you're expecting us to say our products work, right? But there's nothing better than actually, talking to WISPs and seeing what they're doing and how they're improving their networks with our technology. So RFE Lab is one way of connecting with kind of the horny WISP user base out there and seeing what other people are doing. YouTube is by far my favorite source and favorite place to go. So our YouTube channel has tons and tons of videos, customer testimonials. We do this thing now called WISP Traveler, where we actually travel to go visit WISPs, and we kind of do a little documentary on how they found their technology, how they transitioned to our technology, and where they are today based on utilizing our technology from where they were before. And this is really a great way and a great resource because no two WISPs are alike, right? But there's certainly kind of groups of types of WISPs. And if you go to our YouTube channel, you'll probably find a WISP that's facing the same issues that you're facing, dealing with the same type of areas geographically or types of customers or what have you. You'll find something there that you can relate to as far as the type of problems you're trying to solve, and you can see how a very similar WISP like yourself has solved that problem with the RF Elements horn antenna technology. So great resource there. And finally, stay tuned. We're working hard. Our antenna technology really is extremely high quality from all aspects, not just the build quality, not just the RF performance of it. So these good things take time, right? So we take time to make sure that what we bring to market will deliver exactly what we say it will in the spec sheet. So there's no secrets there or marketing fluff behind our stuff. So stay tuned, because we're working on some great technology. So check out our website, rfelements.com. Again, our forum, rfelab.com, or social media, right? We're all over social media, whether it's YouTube, Facebook, Google+, LinkedIn, Twitter, you name it. We're there. That's a great way to connect to us. It's a great way to ask us questions, but better yet, it's a much better way for you to connect with the community and your actual brother and sister WISPs out there, and hear from them how they're using technology and how it's benefited them and how we could definitely benefit you some. So with that, I'm wrapping it up here, and I'm ready for questions. I hope we have some, and if you have not already typed in a question in the question box, do it now. I like follow-ups. The more questions you have, the better. If anything I said doesn't sound like it's possible, please ask it now, and let's address those questions. Thank you. To you, Violetta.
Yes, so we're ready to take questions.
Is anybody typing them in the box?
Nope. No.
Okay. Okay, well, if you have any questions, I'd be happy to take them. Again, you could post them now, or you could always email us as well, info, I-N-F-O, at rfelements.com, or you can even email me direct, Tassos, T-A-S-O-S, at rfelements.com. So if there's no questions, then...
All right, so we have come to the end. We are recording this live, and it will be posted on the ISB Supplies YouTube channel. Additionally, I'll have the live recording sent to you through email. If you have any further questions, feel free to contact our sales team at 855-947-7776, or email us at sales@isbsupplies.com. Or as Tassa has said, you can go ahead and contact him through RF Elements. Thank you, Tassa, for presenting, and thank everyone for attending. Have a good day.
Thank you. Bye.
Bye-bye.